Hello everybody, welcome to Conceptual Physics. This is our second lecture, PowerPoint on Chapter 2. You will need this for your next assignment. Okay, so we're talking about acceleration. So we talked about speed and velocity and acceleration just a little bit last time, but acceleration is our main topic today. So the first thing I wanted to talk about was, acceleration is a change in velocity. So anytime anyone says you have a constant velocity, that means you have a zero acceleration. Okay, and that's the normal label for acceleration is meters per second squared. Okay, this point is saying that an object that is accelerating means its velocity is changing. Now here's where things get a little bit weird. Speed is what you're used to knowing and understanding change. So like if I say you're going to accelerate, that means you're stepping on the gas pedal and going faster, right? But direction now is also part of the acceleration because velocity has both size and direction. So we said before that velocity is called a vector, and a vector quantity has both size and direction. And so if you change either the size, which is the number, or the direction, then you're still changing that vector quantity. So here's the first thing that you got to know. You don't need to speed up to accelerate. You need to change your velocity. So if you accelerate, that means your speed, which is how fast you're going, is increasing, or your speed could be decreasing, or you could be changing your direction. Okay, so any three of these ways to change your velocity would be considered an acceleration. Okay, so just like I said, if a car is speeding up, it's accelerating. If a car is slowing down, it's accelerating. But notice this note here says that it has a negative acceleration. You see that? So deceleration or deceleration is pretty common, but they're getting away from using that. Instead they'll say a negative acceleration. But a negative acceleration would slow something down only if your initial velocity is in the positive direction. So if you have a velocity that's in a positive direction and you have an acceleration that's in the positive direction, then that means your speed is going to be getting greater. If you have a velocity in a negative direction and an acceleration in a positive direction, your speed will be getting smaller. So this is a good thing to write down. If you have a velocity in a positive direction and acceleration in a negative direction, that means your speed is getting smaller. And if you have velocity in a negative direction and an acceleration in the negative direction, that means your speed is getting bigger. So the moral of this story is, if your velocity and acceleration are in the same direction, whether it's positive or negative, that means you're going to be speeding up. If they're in the opposite direction, you're going to be slowing down. Now, how do you know what direction is what? Well, here's your first clue. If you say that direction is positive, then by default, that direction is negative. If you say up is positive, by default, down is negative. So it's really up to you. So when you're going about and doing your problems, whatever you say is positive, then the exact opposite is negative. And those are the only two directions that we can have in any formula. And, you can only have two directions in any formula, it's the positive and the negative. So this next note says a car going around a curve at 30 miles per hour of a constant speed will have an acceleration. So how will it have an acceleration if it has a constant speed? Who can tell me the answer? Thank you very much, Corey. That's exactly right. It's changing direction. Hey, go ahead and clap. It's exciting to have a... Yay, we all win together. Okay, so here's your car driving around, right? At that constant speed. And it's constantly changing direction if it's in a circle. You know, because at this point it's in this direction. Here it's in that direction. Here it's in that direction. And so it's constantly changing direction. That's called acceleration. Okay, so here's the formula. The acceleration is equal to a change in velocity. Yep. So change in velocity, change in is delta, v is for velocity, divided by time. And so delta t. Now you don't have to write this formula down unless you're just interested in knowing what it means. This is what it's going to look like when you use it. V minus v sub naught divided by t. So v sub naught, that's at not at like nada, like no time. So it's your initial velocity, and v is your final velocity. So the one that has no subscript is your final. The sub naught is your initial. That's real common with the physics formulas to have that. One without and one with a subscript. But that's a zero, which means that's zero time for initial. Okay, so that's your formula. And then the last note of this page is just some common labels for acceleration. So meters per second is the same thing as meters per second squared. Now centimeters per second is kind of common, or centimeters per second squared. Kilometers per hour per second is also kind of common. The one that I'm most concerned with is the meters per second squared. That's the one that will be kind of most common for the rest of your physics classes. Any questions? Okay, so let's give it a try, this math. So make sure you guys are taking notes on this. But let's just say that we have a car. Oops. Here's our car, right? And we'll say that it starts at 0, so our initial velocity is 0. And you should make a checklist each time. And we'll say that our final velocity is 20 meters per second. When I say checklist, it's always going to be the same variables. Our acceleration is unknown. Your acceleration, though, we don't know what it is. But we do know that the time that it took to do this was 4 seconds. Okay, so you look at your formula. Acceleration is equal to v minus v sub naught divided by t. So once you have this checklist, then you should be able to do the math. So make sure, if you're having problems with this, you make a checklist, and then I can help you. Otherwise, I'm not going to help you if you don't come with the checklist, okay? I'll help you, but I'll tell you to make the checklist. So my initial velocity, or my final velocity is 20. And notice, there's no sign here, so I'm going to assume that it's positive. Okay? My initial velocity is 0. I'll divide it by 4 seconds. My acceleration then is 5 meters per second squared. Okay? And that's in the positive direction. Okay? Because it came up with a positive sign. Any questions? Okay, thank you very much for that question, Riley. That was a great question. The question was, can we ever have a negative because speed is always Okay, I guess the question was, because we're always talking acceleration and that means going up. So, and that is true, like when you say accelerate until you get to this class, you're probably thinking speeding up, right? But this is where that changes. So, let's just say that we have an initial velocity of 20 meters per second, and our final velocity is 0. What does that mean? What happened? You're slowing down. Well, you come to a stop, right? But you don't know what your acceleration is. And let's say that it took 5 seconds to do this. Okay, so let's see what happens this time. So when you do your math, you guys, this is your first line. You always have to have your formula without the numbers. And then the second line should show the substitutions. So in this case, your final velocity is 0. Your initial is 20. And that's all divided by 5. So your acceleration then, if you put this into your calculator, becomes a negative 4 meters per second squared. Does that answer your question? Yeah, now look at this. You knew it was slowing down, right? Your initial velocity is positive. Your acceleration is negative. That means it's slowing down, so you can refer back to that chart that we had before, and this is holding true there. Okay, so we're going to do another one. Let's just suppose that this car is steadily increasing its speed, but let's say that the initial velocity is 30 kilometers per hour, and its final velocity is 35 kilometers per hour. The question is, what's the acceleration? Okay, so we'll say that it takes 10 seconds to change this velocity. Okay, so this time there's no 0, so you're going to have to put in both the numbers. So your first number is 35. Your second number is 30, even though, you know, they're always an opposite. Final is always first, initial is always last. And that's all divided by 10. Okay, so your acceleration then is going to be 0.5, and I wanted to say meters per second squared, but we have kilometers per hour per second. Okay? And that's because this time was in seconds, and these were both in kilometers per hour. Okay, do you think you got enough to go with and do a couple questions for this quiz? Okay, we'll stop here. Have a good day.